you haven't been described recently. Haven't you? Yes? Huh? Can you be... That's okay. Can you be described? No, maybe not. Are you?
No.
Are you? Yes. Alejandro, would you mind to be described to them? You could just say it.
No, yeah.
Okay, thanks. I have fewer and fewer survivors in this class, so now you'll be doing the scribe. Thanks a lot. All right. So I'm going to introduce tableaux, which will go in the exam with probability 1, and also it'll be asked thoroughly because it is a very important learning goal. And then we'll solve the problem that I set to you yesterday. So you may be kicked out in the middle of the class if you haven't done that. With the exception of Hara, who didn't come yesterday, and also we had a problem with the videos, so that's why you're safe for now. Okay, so we have a formula here. Analytic tableau. That's a strange word. It's a French word and it's pronounced à la française, as they say in English. In English, when they want to be cultured, they use French words instead of Latin words or Spanish words. So, what's that? Here I have my problem. Given a formula, find its models. Right? Find its models. On the way, I'll solve another problem. Determine whether F is tautology, contradiction, or contingency. Well, once you have determined all the models, it's very easy to answer that question. So, ideas was the very first idea that comes to your mind. Yes, Marius?
To make a tree of the formulas. And then
that's the first idea that comes to your mind. Unbelievable. Well, yeah, there is a tree behind. Normal people would say truth table. Let's make the truth table of the whole formula. Okay, good. Let's call P well, let's use substitutes, otherwise it's going to be a mess. So, let's say that you want P to are variables. If you want to be more precise, capital sigma. Let's call P the set of the propositional variables appearing in F. How many rows will have the truth table of F. Question. 2 to the nth. Right? Suppose I have like a normal application, you may have 10 or more variables. 2 to the 10th is 1024. Right? So it's a lot. This is not practical at all. It's really brute force. So I'm going to use another approach which is much more sophisticated and is based on the idea of a tree. But it cannot be any tree. It must be a tree with certain properties. The tree is called tableaux. Right? Tableau. So first, yes, Alejandro?
What did you wrote there? How many rows?
Rows, sorry. Yeah, and I said was missing. Very well spotted. How many rows? So this is going to be long. I'm going to classify formulae first in a special way. Right. So first step, formula classification. So I'm going to classify my formula into 4 categories. Okay, those are propositional variables. The 2 local constants. Negations of propositional variables. This is merely this descriptive. What else? Simplifiable formula. Negation of formula. Okay, and now I'm going to classify into the 2 main categories: disjunctive, disjunctiva, as an adjective. Can you tell me formulae that are written just in terms of or? Yeah, well, I'll give you one. A or 2, A or B, another one. Now you have to use the logical equivalencies that I told you to study yesterday. That one is of this kind. Why? Because if I apply the Morgan law, what I get is no. Yeah. Not A or. Is this formula of the disjunctive kind? Yes, it is. The other day I proved that it was equivalent to that. Yeah. Remember? True and true? True?
Okay.
True and true. Well, I'm writing one or two in distinctly. True implies false is false. False always implies true, whatever the conclusion is. And here I have not true or true. That's true. Not true, which is false, or false, which is false. This is true. And not false, which is true or false. Right? So these two formulae are equivalent. Right? So this formula is of this kind, a disjunctive formula. Right? This one too. And this one too. That one I leave it for you, but that one is equivalent to this. Right? A by conditional B is A implies B, and B implies A by definition. Right? And then that one is of disjunctive kind, and the other one is of disjunctive kind. Then you have to apply the distributive property that I left for you. But at the end you have something written in terms of or, logical or. Okay, and finally, conjunctive formula. Well, we have only three. K and D, not A or B, and the negation of A implies B. Right? This one is just true because of the Morgan's law. And this is the negation of the other one. Right? So, no problem with that. So I have my formulae classified into these four categories. Right? That's the first step. And second, I'm going to erase means grammar and many other things. So I'm going to construct a tree, the tableau of F. So I'm going to give the rules to construct that tree. Okay. So understand that what I'm going to write down is the formulae, the rules that apply at all levels. This is a recursive definition, right? So simplifiable formulae. Every time I see this, whatever it occurs in the tree, I just branch that way. The negation of true will be false, branched in that way, and the negation of false will be true, branched in that way. Okay, nothing complicated. So that was disjunctive formulae. Well, I have that. I branched in with two different branches. Right. So if I have that, how would I branch? No.
Not A and
Yeah, not A. Yeah, I'm just branching according to the logical equivalence, right? More. Here, what do I do? Yes, absolutely. Okay, those two. That's much more complicated. Not much. Later, I'll prove that fact in the exercise. For the moment, just believe me. Late to my account. You don't know what it's going. Just trust me. That's what it means. Late to my account. Finally. Although you can see here you have A implies B, which will give an or, two branches, right? And then you have and B implies A, and then you have this kind of branching here. It's not very easy, not very hard to see. Okay, and that takes account of all disjunctive formula. Well, some people just write an arrow. I don't do it, but some people write an arrow here. Everything is top down for me. Right? So, well, if you write it, that's all right. If you don't, also it's all right. So that's conjunctive, A and B. What do I write here? No, 8. No. Now finally, put out here. Because this is not A or B, the negation of this would be A and not B. So those are the branching instructions, right? So now let's see how the procedure works. Yes, Marius?
Okay, we go top down, but can we change the...
Absolutely, absolutely. No problem with that. Here, well, there you cannot change anything, but here it doesn't matter the order. At the end, I'll prove that no matter what the decision you make in the middle, you'll get the same result, maybe not the same tree, but you'll get the same models, which is, in a nutshell, what it matters, right? So, branching process, hold conditions, that would be 3. Step 3 of the condition. You know, halting. So, halting. Halt means parar, stop, right? It's a technical word. So because, well, here I start with my formula, F. I determine the main collective. Depending on the main collective, I choose a particular branching process. Right? Suppose F is just for the sake of an example. Suppose F is of that form. Then I will do G1. Well, okay, I don't want to get many subscripts. So I will get that. Well, then I have to carry on and say that G1 is of the form G3 and G4. G3 and G4. And here say G2 is of the form G5 or G6. Etc. 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 Right. So when do we stop? Was a halting condition. Yes,
G1, why are you doing the branches like up to down?
Yes.
You have to divide it into 2.
Yeah. Define something. Your question probably?
G1, you have to divide it into 2 branches, G3 and G4. I think.
Here?
Yes.
No, because I just said it was and. It was a conjunctive formula. Right? I'm going to make an example right now as soon as I finish the halting conditions. So halting conditions are 2. Well, one of them is very clear. You find one of these 4 situations. P, a negation of P. Here P is a variable. Or one of the logical constants. Right? And now I'm going to introduce the concept of closed branches. So here you have your formula F. You have branching. Suppose you are here and find a subformula, say G, right? It may not be a literal, but by the meaning of formula. And from the path from this formula to the root, suppose you find the negation of G, right? This is the path. That path is unique, by the way. It's a tree. It's only one path from G to the root. Okay, at that moment you stop. Mark that branch as closed. Typically you just write close and stop. You don't carry on, you don't continue, you don't develop your branches any longer. Right? So those are the two halting conditions. Either you just go down, deep down, until you get one of those, or you stop before, because you found the negation of a formula and the formula itself. Right? Okay, you may be thinking, we are not going to get the models out of this, but we will. Let's put some examples just to see how the process works. Here I have some examples prepared. Okay, very simple one. Okay, so I apply, well, first of all, I need to know what the main connective is, right? This is very important. So it is or, the logical or, so it is a disjunctive formula. So in that case, okay, I check every time I develop something, I just check the halting conditions. Am I in one of the halting conditions? No, because here I have a whole formula, so it doesn't apply rule halting condition number one, and here I have another formula which is not a literal or a negation of a literal. So I carry on. Can I apply rule 2? No, because here I have that formula which is not a negation of that, and here the same. So I carry on. What do I write here? Not P or Q. Okay, here I'm done. Because I apply rule number 1. Halting condition number 1. Number 1. And here I say not Q and P. I'm done. Right? And from that tree, once is already constructed, I can infer the models. How? Okay, I take an open branch, say that one. Typically you write a little O to say open. And go from the node to the root. I just one path, because it is a tree. In this case, I'm taking not P. And just write down all the simplifiable formulae that you find on your way. From here, I just find not P, right? Not P, nothing, and nothing. So this is giving me two models. P equals 0, because I found not P. And if I don't find Q, anything goes. So I can set that, or I can set, yeah, those are different models, right? So is that true? Yes, it is, because if P is 0, this is going to be true, whatever I set here on the other side. And Q may be yes, 1 or 0, right? If I go from here, the same thing. I'll get P, nothing, only P. So I just found P, which means this is true, and then it is also a model. You may check it. If P is 1 and Q is 0, this is 0, but then this is true. And if P is 1 and Q is 1, then this is 1 and it's still true. Right? Some models can be the same. I'm not saying that you get all the models, disjoint models. You may have repeated models, but you just cancel them out and that's it. Yes, Alejandro?
I understand when you do the tree, all of that, but I don't understand since you take the from taking the open branch.
Okay, so here I have my tree, right? I just look for the open branches. That's it. I don't see that symbol, that close, right? So here everything is open. There is no closed branch. So I just take one branch here. That's one. And then I go from that node, that lead is a lead, right? From that lead to the root. And I take notice of all simplifiable formulae, right? Which were propositional variables, logical constants, and negation of propositional variable. Right? So here I see not P. Right? So not P, I go from here not P, this is not a simplifiable formula, and this is not. So the only thing I get is not P out of that path. So not P means that P must be false. Right? So I set P equal, in the evaluation I set P equals 0. What about the other variable? My branch says nothing. Right? My branch says nothing about it. Yes, it means that you have the freedom of setting that variable as you wish. So, well, I have two values, true or false. So P0, Q0, P0, Q1. The only two possibilities. Right? Absolutely. Yes. That one? Then that's true automatically. That's it. Here I could have P equals 1 or P equals 0, which is the same as that one. Right? So I said you may get repeated models, but you discard them. Okay. Let's do some more complicated stuff. and or negation. And that is right. Yeah, because, well, maybe it's one of my faults. That's a parenthesis. Yes. Okay, pay attention because here it comes the place where most of the people make the fatal mistake. Fatal, but don't apply to women because it means something else and it's very offensive. In English, mujer fatal is femme fatale, using the French words. So fatal woman is something very good. Okay, perfect. Do I have? Am I done? No, because I don't have literals of negation of literals. So I'm going to develop that formula next. I may choose, right? May take that one or the one, but I'm going to take that one. So what do I write? Sorry? Right. So what do I have to write? It's not or and. So you must memorize the logical equivalencies, right? That's why I didn't want to write them down on the blackboard to force you to memorize them as soon as possible. Also, you have to memorize all these equivalencies, all these branches thing. But once you memorize the logical equivalency, that's very easy. So I'm going to wait. I don't have more room. I'll carry on up there. Okay, so am I done? No, because this formula hasn't been processed. Right? It's very convenient to check your processed formula. Right? So what's next? Here, that's clearly conjunctive formula. So okay, now I check the Halting conditions. I have not R, Q. Questions, comments, suggestions, results, praises? Nothing. So that's checked out. This is our literal, this is a renegation of our literal. This is on my to-do list. So now what do I have to write down? Check your notes. I don't think you haven't done it. No? Yeah. And here the mistake comes. So far so good, right? May I close something before going to the mistake? May I close something? Because sometimes people don't realize that they could closed branches, so they get such a big tree. The right, yes, because if I take the path from this guy, from this negation to the root, it would be not Q, not P, blah, 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 then I have Q and not Q. Right, so halting condition, that's closed. I don't branch it further anymore. Right, so I just carry on that one. But the mistake, suppose this branch is not closed, right? Now I have to close it back one, right? The mistake most of the people do is they forget that this must be developed on all the subtrees, right? Since this is closed, I'll just do like that, right? But if this one were open, I should just write 2 branches to it, right? That's the thing that people forget all the time. But we'll make around, here in the class, we'll make around 15 trees, and at home you should do like another 15 in order to get the hang. So, here I'm done, this is closed. And here there's a good word to learn. Closed when something is, and close when something is very near you. Closed. So that one,
Close.
yeah, closed. Because here I have P and not P. Here I have Q. Okay. So I want to get the models. I just locate my open branches and I go from the lead to the root and see what happens. So I get Q equals 1, P equals 1, R equals 0, and U was already set. But U was already found here, so I don't have to set it again. And that's my model. Do I have more variables? No, that's it. That's the only model. Right? Again, you'll be asked this in the exam. Yes?
Shouldn't be where you put negation of P, which is closed, in the other branch? Shouldn't it be R instead of?
Yes, sorry. Yeah. It's good to mention. And how it doesn't change the thing, then yeah, it changes. Sorry about that. No models. No models. Okay, I have one quickly. Right? The main connective is an implication, so it is not A or B, it's a disjunctive case, so it's well balanced. Alright, so I'll take that one, which is everything is open on this side. What do I write here on this side? P or Q? Yeah. Because this is an or, and I have the negation of an or, the Morgan's law, that's a conjunction. Then I have Q. So there are no closed branches. In fact, it is a tautology. That's a tautology. Although the normal way to do it is to negate, is use aspect that it's a tautology. You negate your formula because it is easier to get closed branches instead of, because you understand why, right? Because here immediately you get many closed branches, whereas here you are going to get all the models. You have many variables that are going to be, you are going to have a very big, large tree, right? So when you take all the paths way up the rule, then you get all the models. That's a lot of counting, a lot of enumeration. You want to enumerate them, there's no way. You just want to know whether this formula is a tautology or not, then it's better to take the negation. Okay guys, enjoy yourselves.